So for this video, we're going to find the area of the region between the curves f of x equal 4 minus x squared and g of x equal to x plus 2. So the function f is a parabola that opens down because of the negative coefficient of x squared. So you got parabola that goes like this. G of x is a linear function, so it's a line. So we're expecting an intersection like this. Otherwise, we won't have a region between the two curves, contained between those two curves. So what we want to do is find the points where these two intersect. So we can do that by just setting these equal to each other. So 4 minus x squared equal to x plus 2. And again, we're looking for this area between the two curves. So let's move everything over to one side. So this will be x squared. I take it over to the right side. The x will stay there. This side then will be the 0. 4 goes over. It's minus 4 and 2. So we have minus 2 here. Then we can factor the right side here. Be x plus 2 and x minus 1. Set these equal to 0. Product to 0, so we can set these equal to 0 from x plus 2. We get that x equals to negative 2. X minus 1 can be 0 when x is 1. So these two curves are intersect at the point minus 2. Plug it into either one of these, it doesn't matter. Put a minus 2 there, squared. 4 minus 4 is 0. Minus 2 here, and 2 is 0. So the y value is 0. So the two graphs intersect at one point minus 2, 0. And when you plug in 1 here, you get 3. Or plug in 1 in the first one, 4 minus 1 squared, that's still 1. Gives me 3. So the point of intersection of these two graphs is going to be at minus 2, 0 and 1, 3. So that's the information we need. So this is what your graph would look like. They both intersect at the point minus 2 here, 0. And then this point over here is 1, 3. This is the point 1, 3. And of course the top curve is the parabola, or f of x. And this is here g of x, the line. And we're looking for this area in between these two. So we get a rectangular strip here. The area of that would be the length times the width. The length will be this distance here, which is f of x minus g of x. And then the width will be dx. And that's how we get the integral. So the area is going to be from this point, minus 2, all the way to this point over here. So it's going to be from minus 2 to 1. And then this is the representative rectangular strip. And of course, what the integral does is it sums all these little rectangles up to give a pretty good approximation of the area between the two curves. So that's the interval we're going to integrate on, minus 2 to 1. And then it's g of x, or I should say f of x, which is 4 minus x squared, minus, top minus the bottom. So that's minus the g function, x plus 2 here. So the area of the representative rectangular strip is length right there, which is this difference here, times the width. It's the area of a rectangle. And then this notation here, of course, the integral, the integration here from minus 2 to 1 just sums up these rectangular strips and gives me the area. And of course, the width again is represented by dx here. And then we go ahead and do this difference here. So the minus x squared is going to stay. And I'm going to have a minus x from here. And then the minus 2 and a 4 gives me a plus 2. So that's the expression we need to integrate. Just a regular trinomial. So then we integrate here. Add 1 to the exponent here, we get minus x to the third over 3. Then minus x squared, add 1 to the exponent, divide, minus x squared over 2, plus 2x. integral of 2 with respect to x is 2x. And then we evaluate from minus 2 to 1. So this is going to equal to, then we evaluated 1, replace the x by 1, and then we subtract by evaluated at negative 2. So we replace the x by 1, get a minus 1/3, minus 1/2, plus 2. And that's going to be minus the value at negative 2. So put a negative 2 here, negative 2 cubed. It's a minus 8, and then a minus there. Going to make that plus 8/3. Minus 2 here, negative 2 squared is 4, divided by 2. And then you got the negative, so this will be a minus 2. Then minus 2 here, be minus 4. Then we just compute these out. So the first parentheses, common denominator is 6. So I'm going to put 6 right here. Just go 3 into 6, 2 times the minus 1 is the minus 2 here. Again, 2 into 6 is 3 times the minus 1. Minus 3. Then 1 into 6 is 6 times the 2 is going to be a 12. Next one, common denominator will be 3 here. And of course we can add these up. That's minus 6 here. This will be 8. Minus 18. I'll finish it over here then. Combine these up, we get 7/6. This will be a minus, and this will be a minus 10. Minus 10/3. You got 7/6 plus 10/3. Common denominator is 6. Let's multiply here by 2 and 2. So 7 and 20 will be 27/6. Reduce it down, divide by 3, we get 9/2. And that's square units. The area of the region bounded by this parabola and the line is 9/2 square units. Thanks for watching, and we'll see you next time.